recording for this session. All right. Right. So today's lecture is about the introduction to VR and AR. Yeah, okay. So the first thing, it's kind of two different technology, but you will see a few has an overlapping area, but we'll introduce them as a different part. Okay. So the first thing here is a virtual reality. Toward the last lecture in the recording. Oh, by the way, sorry about the recording lecture last week. So you probably haven't got time to look at them. But please help look at that. Assignment 2, lecture 2 is about general introduction into the unit. Lecture 3 is really important part of the design components. You should pay a lot of attention to that one, okay, and both of them. But the last one, I will visit them as your project is get going, and so on, and assignments. So for this one, it's virtual reality, okay. So this one is, as I explained in my record lecture. So this one is sit inside when your humans sit inside environments. So this one is your human in the blue here. Okay. Can I double check quickly? Can you see my mouse moving? I think you have, right? Yep. Yep. Okay. Thank you. Yep. Thank you. And so this one are basically human is sitting inside environments. You cut off from a capital R reality, okay, and you sit between the yellow highlights. Capital C here is a computer generated, and you can see the X disconnecting part here. Okay, so that means that you're inside that environment. Okay. So and also toward last lecture 2 on the interface, I also talk about virtual environment and the spectrum continuum that the Minkum generated in the paper 25 years ago. So we're on the other opposite end of the spectrum, okay, in the virtual environments. So the way to generate this is a very old kind of, but it's still valid in terms of what the architecture look like. Okay, so the starting from the very virtual environments on the right hand side here. Okay, but inside here now, it's probably you don't have to get to know them now because now they sit embedded inside a GPU as well as a Unity game engine to render whole thing here. But I just get a little bit of a understanding that. So you have a CPU here, host processor, you have a data models or whatever you store as a data, and you have rendering. So some of this will be a GPU stuff, and then a buffer frame to generate the ability to generate frame by frames. Okay, so and you have a display driver, and you have this little optics here, which is really a display device, the VR headset. Okay. So this one, and you have the head tracking, which is one of the lecture later on. We'll talk about what is the technology behind that. Okay, which is essentially that's what the immersive environments are coming from. Not just optics in front of you, what you see, but the ability for you to look around yourself and the ability for the head track to track where you're heading. So therefore, what you see reflect where how your head is moving. Okay, so this is a major difference. Okay, so this is the headset in the market now. So there are quite a few hand copy of these things around. We in our unit we've been using a few version of this. Okay, but in a practical sense now, it's the number one choice now is Oculus Quest, which is a little portable unit, which will kind of suitable for what we need in a lot of application now. Okay, so I think someone knocked on my door. Um, so some of the VR application here, okay, so this is what we talked about before, flight simulator, okay. So this one is what we discussed in my previous lecture, is that how you simulated environments, you can control different components. Can you give me a second here? I need to go and talk as someone knock on my door, just a second. Okay. So this one, as you can see here, is a simulators. It's basically can generate what it's supposed to see. The reason the flight simulator is quite famous because not only because it's a very critical task instead of have a new pilot training on on the real plane, but it's also is you can see here reality in a cockpit is not that much. If you see outside the window, that's pretty much all there are in most of the planes. So it's much easier to make a software that make a simulation that makes sense to them rather than try to simulate the whole environment. So now you just have to simulate the one on the front. Okay. So this one it has control components. So this one is a virtual completely, but in the normal flight simulators, you have a hydraulic gear, so you allow your whole module to move around as well as a physical handheld in front of you. Yeah, but this one is actually what as we know. But nowadays people are using that for gaming. Okay, so we've seen some of this in the past 5 6 years. It came out on the market. Some of them make it. Some of them didn't quite commercially successful. Okay, so you can see here optics, and you can see the environments. You get to very immersive into that. So that's what this unit is about. Is to try to get you to understand what it really make it work and how what's application should be made of. However, besides from this obvious game and things, so also application that are more subtle. So like for example, we have a Parkinson disease. So it's a very difficult, patient would have difficult sustained walking. So they end up most of the time shaking a little bit, shaking kind of repeatedly. Okay, so this is what become known. We have done this in the lab. Researcher done this back 25 years ago when they put someone in a virtual headset, okay, and allow them to see the pattern. The pattern here is on this reflect, clone it into on the monitor here. Basically, is projecting the chess checker board on the ground, allow them to see a pattern, which is the known that are to be helping a patient to be able to walk onto this pattern floor. So this one it become they did a bit of a study there. Okay, early of the VI, the headset then is very limited, but at that time they still see a difference. Okay. So there's a few articles here that people start using them. Google Glass was no longer available. So, but that one has been tried to use so some of these. So this is attention that pay here should pay here is that the VR is not just a gimmick. So some researchers are using this for some interesting work. Okay. And another work that quite interesting. So this is also in the early days of VR, but they recognize that this one is a very interesting one. This is what the VR headset back then. Okay, so this is 2000. So you can see here the headset that has a hand. Patient here has a accident, has a burn, and has a in pain that the nurse on the left hand side are doing attend to his wound. Okay, so this is a quite a painful process. Okay, so for because the patient need to do that every day. Okay, so to prevent the bandage to be integrated, merged inside the new tissue that growing back to replace the burn one. So that's they have to make sure that that not happening. So they have to rewound them every day. So it's quite painful. So this has become a one of the project that were interesting to look at how to do that, effectively. So this is another person. Okay, this study happened in Seattle. So there, yeah, has said there's a burn patients, there's a component that people are looking at them. So the patient here, they're using VR not to try to extract or distract people from what they were supposed to feel, which is a whole lot of pain. So in this case here, they were looking at different things. So you might have seen here, this is a little attached with a tracking system, but essentially in the patient VR view, it's basically she was just looking at a virtual object, okay, a virtual object representing inside her VR view, And then her hands here, he also has this little cable, a little attached to her tip of the finger. So that is another object tracking that allow her to see the tip of her finger point, finger, and then basically she can move to that object. So that object could be anything that actually can be moved inside in the physical world and represented in the virtual environments. Okay. Which is a very interesting one. So this is a just get basically just distract her from what she was currently in situation. So this one, okay, so this one is also as patient. So this is a work you can see here. There's quite a lot of work to go through to get the people who's inside. And then this is the image is not very clear. It's a joystick, okay, and then that's a BIS set. And he also one of his hand is also under treatment, okay. So they will try to look at how things are helping, okay, inside. You might have wondered what sort of environments people want to be in. Okay, so it's just looking at the games or all those sort of things. Okay, so lead researcher of this project from a psychology background. Okay, so what he came up with is this is a snapshot of view inside that patient that treat for a burn patient. Okay, so this one has we call snow world. Okay, so basically what you're sitting here is a very simple game. Remember, this is all more than I think 20 years ago. You're riding on a trail, a track, and then going around this frozen, icy, snowy mountain. Okay, and what you did, what the patient has to do is basically look around and then try to use the joystick and control the shooting to shoot those snowmen, because essentially snowman will try to shoot at you, so you should try to shoot back. It's just simple, very simple part of the game. Okay, so one of the things that, but it's quite remarkable the way they're seen. Okay, so that's is basically why would he choose this sort of environments? Are they have any effects on them at all? Okay, so you have any comments? Anyone want to like to have a guess? Okay, why would people want to have these environments? Why he chose to have this environment? Yeah, I should say. Yep, I think that's one way to do it. Okay, so that's exactly right, Joe. So this is intentionally make it look cool, look cold that they're in a freezing environment. So therefore, they subconsciously start to kick in that they're actually in cold environments, when in fact their part of their body, in this case, is his left hand, is actually in the burning sensation due to his injury. Okay, so that's is a start to look. So researchers in this area start to recognize that when you put people in immersive, you might be able to certain distract for the benefit of themselves, for their own benefit in this case, to extract them from that component. So that's what become very interesting work at that time. Okay. And the early work of that before the leading that is much simpler is treatment of spider. Okay, so it might look like this. It looks okay. Okay, so this is for treating spider phobia, because it's just kind of before that snow world, people will start to recognize that VR might be just using Moderna games. Okay, so this one is the same thing, but the trick for this one is a bit tricky. Okay, a little bit kind of clever actually. So in this case, it's inside a VR environment. So you have this virtual odd-looking spider that's moving around, and then the patient is want to be treated to spider phobia. So in this case, it's a low exposure, gradual, repeat exposure. Hopefully, they're aiming to improve the condition. Okay. The key here is very difference. I think these patients that are going back to a few slides here. Remember that I talk about this. This one, this is exactly what spiders look like. Although she's not treated for spider phobia, she clearly is treating for something else. But this one is what spider phobia usually people do, is that you have something that tangible, has a little creepy, that feel like creepy, like when you close your eye and you kind of touch on them. But since they're attached with a tracking system on them, so as soon as your hands is actually touching them, remember that now you see them inside a virtual environment, you think they're not real. Okay, so just imagine this, and then your task is to grab your hands, your physical hand to that virtual spider. Okay, yep, yeah. So, well, that's I think you might be candidate for this, Yukong. So to go for this. So essentially here you grabbed it. So people with spider phobia might just feel a little bit less less scared for this one because they realize that this is not the real one. But the treat for that one is that at the location of that spider is actually located with a physical track object, okay, which is really something that if that thing is moved, so when you try to grab that, let's say you imagine you use your physical hand, grab that virtual content, and at the end of that, you grab these because they're essentially, remember, they're the same thing in the virtual because being tracking position inside the real world. So if the spider moves, I mean, in the real world outside here, the virtual object, in the physical world, it will move inside the virtual world as well. So essentially, they're the same entity in the class, both virtual and physical. So what that means is that a patient will get a kick out of this one because they feel the object at the end. So they kind of try to expose them to a low exposure component. Okay. Yes. So Ethan. So yes. So that's is but haptics here are very different. So this is not a force feedback haptics. So it's just a presence of objects. Okay. So that means that yeah. So therefore you might be well, I mean, this one is definitely one of the tricky one to do. Okay. Yeah, so that's right. So essentially, you get the idea here because now you have ability to actually translate your physical object and get them inside the immersive environments, and that you have the two of them to work together. So that's come to the good effect there. And also interaction of the spider and yourself is also key. Okay, so but the whole idea here is that once you immerse them, uh, I'll try to jump back to the first slide here. Now you put people inside the virtual environments. Okay, you're in the kitchen, virtual kitchen, which is a capital C here in yellow, and then you disconnect them from the real world. But there's no reason for the back end for that little four, eight leg objects that hanging on from the ceiling to actually represent thing inside the virtual environment. So these boundary, as far as system concerned, can be blended, but that's it's only can blend that because people cannot see the real world. Okay, hopefully that makes sense. Now, so this one is more less complicated. Okay, so you probably can get this very clearly inside tutorial. So treatment of height. Okay, so so this one is so you can get a sense of how um, I think the very at that time the VR system is not that complicated. So, but what you want is to get people to wear this system and see them from outside, observe them from the outside and see them try to balance themselves over a normal floor because you simply put a height of the edge of the building there. Okay, so this is quite effective. I think this one is quite easily done in the current VR technology. Okay. So so that's one, and then this one is also using for a lot of treatment for public speaking. Okay, so this one is this is his view. Okay, outside what he's seeing, and then remember his head is he not see a fixed image here because his head is being tracked positions where how he rotated, how he moved his head, so that the image that appear to him appear to be stabilized in space. Okay, so you can see here audience in front of him. Okay, so this is just to practice his public speaking. Okay, so and then the trick for this one is not just seeing static avatar or something pre-play the video. The key for this, which is currently people are doing research in this space. Okay, toward the end, I think one before last slide, before last the end of lecture, the end of semester, I'll talk about research inside this space, and I'll talk to you about some of these that it look easier than done, but it's actually one of the difficult part for this one is that how to generate the how to create a real illusion, in not just a visual illusion, but interactively, cognitively components that allow them to feel like they're actually inside with other people in the environments. Okay? So this one is actually people need to interact. The eye contacts are key. Okay, so therefore this one and I think some of researchers are looking at to use this to be teaching for teaching tool to augment a school teacher, that being the study to be a school teacher that has to deal with trouble classroom when students have some medical issues require attention. So and many of them is inside the same room. So how do they deal with that? Not just public speaking. Okay, so there's all kind of things that you could do there. This is hopefully a spark ideas of how how you get the whole VR. So it's not just gaming, shooting stuff. Okay, so that's a fun too, but it has more than that. Okay. So that's hopefully get you the ideas. Okay, so this is a device that mostly we'll be using in not in our tutorial, but it's available. Okay, so I will talk about this toward the end of today about the practical session. Okay, so this is what I say before. In my unit here, I've been experimenting with the VR device for many generations, even the last 3 years. So, but now we're settled on this one. Okay, Oculus Quest. Okay, so if you haven't seen that, then yeah, sign up for practical next week. You will see me in person as well, and then we'll see the device that you can play with. Okay, and there's a less capable version called Oculus Go. Okay, so okay, and then there was a full-blown version of this one. I can get this to run on my laptop to show at the practical session, but you probably don't want. You can't check them out unless you have a computer to run them. And we right now we have no permission to go and use the full computer in the lab. Okay, it's only for the practical. So that means it's only for those who has a computer, game laptop, game PC, they can run this. Then you can check out those devices. Okay. So any questions on the VR? All right. So now I'll spend the next 20 minutes or so talk about AR or AR, augmented reality. This one is actually it's quite interesting. Okay, it's essentially AR is a born or generated a field that came after the VR. Oh, Sam, the practical, yes. Uh, okay, I'll get you to your question later, Sam. Okay, about practical, we'll talk about this at the end. The AR here. Okay, so this one is actually to our basic um, contents diagrams. So this one is you can see here the humans here seeing the real world, capital R, right? But the content is right in the middle, so it's become an extra layer in front of you. Okay, so you see a lot of this in the Hollywood sci-fi movie. Okay, so basically anything that has an overlay components. So that's what they call augmented reality. Okay, so in this part, it sit inside the Milgram's continuum, but it sits on this side. Okay, there was a question in it that people ask often is whether AR is the same thing with mixed reality. AR is not. AR is a subclass, a smaller subclass of mixed reality. Okay, so that one, so you basically have a virtual contents. In this case, is this virtual samurai 3D character sit associate and tied itself to this physical board. Okay, and this week Ron is going through the tutorial for AR group. Um, which I will talk about the group later on about what AI is. Okay, so in this case, if the ladies here look through this image to the camera, okay, so they're tied to the front of her head mount display. Okay, so in this case, if she move that physical board which has this marker or a big black border that has a computer vision pattern on it, the computer will recognize. So it's you move the physical board, then the virtual character will move with them. Okay, so that's how it's not just a simple overlay. Okay, augmented reality need to be able to capitalize and stabilize in the location. Just imagine if you have something we call a head-up display. Head-up display is simply just a display, just like Google Glass. It just displays something right at the fixed field of view. So it's all like, for example, the velocity and the speed of the car. Then it always stay there. So every time you want information, you just glance at them. Okay. But for this one, it's actually physical virtual content need to be coexist or co-located and co inside the real space. And that's what require a lot of tracking capability, tracking head position and a viewpoint. Okay, so there's a general two modes of this AR. Okay, so with HMD is a common term, H mounted display. Okay, so the first mode here is called optical see-through. Okay, so optical see-through here, you will see real world directly, and this is usually just a piece of glass. Okay, optics, like optics that you can see through. So that oftentimes the VR headset will have that glass, just like a sunglass, just like a normal glass here. You see through them, but you see past to this glass. Okay, but that's where the trick is. It not necessarily have to come from the top here. The projector could come from the side. Okay, but the idea here is that it's combined optically, like compare here. And as far as the user concerned, they were just looking at the combined image between the red, which is virtual, and the yellow as a real world content. They combine within that side. With this technique here, you will see the real world using your own eyes. So it's like you're seeing through the sunglasses. Okay? But you see the virtual contents that mix inside. So this is oftentimes the device that people use. Okay. Well, at least Meta 2 is now out of business. Okay, but at least it's a quite give you a futuristic look in terms of what the wide field of views of the device look like. Okay, the one who will have a good play with it is the Microsoft HoloLens. Okay, so that one you can see you put your head in here and the whole thing is glass there. Projection it comes from the top. Okay. And you have the head up display. Okay, not head mount display. It's still on the head, but this one doesn't have ability to stabilize thing in space. It's just simply a display. Okay, just Epson done that, and then this one is more manufacturing based. But this one is full blown. You can put a virtual character on space, and you can walk around them. Now, for the head-up display, for the video see-through, it's very useful for the military. Okay, so they are in many forms, in a cockpit, yeah, something like this, a visor, things like that they're using, especially when they're using for information overlay. For example, where the interest target on the grounds are. Okay, so especially in night vision mode. Okay. So some of those is become quite useful, but technically the optical see-through is much more difficult technical problem as far as concerned, because the second one, second mode called video see-through. Okay, so this one is a simple HMD. Okay, so this one is actually came out from academic. Okay, when people can't afford the head mount display. Head mount display now is still expensive, but very very expensive in the past. Okay, so most of the researcher in the universities they can't afford them. Only military or some people with a lot of money. Okay. So this one video see through here is the same thing, humans, but humans see here, but you can see the difference here. Human no longer see directly into the real world environment. They see through the video camera, which is outward looking. Remember that lady with the samurai 3D character looking at? That's exactly a typical stereotype for the video see-through. So you have a camera in front, you're looking out, and you see the real world through that camera. So that's what it calls video see-through. You still see the real world, but you see through the video. Okay? The video camera that you capture. And then now how you combine them is become easier in that sense. So you get the red one, which is the real world image capture, and virtual contents and graphic, and you combine them. So this could be a simple program that you're running, and you project them all together. So you will see the capture a real world image, and then the virtual augmented contents right on top of it. So this one is become easier because what you dial here, just like your tutorial running, some of you, half of the tutorial in our class this week will start AR, the other half will start VR. So the AR part will start to use a webcam and simple thing, and the web nowadays with the advanced and more powerful laptop or not laptop, the mobile phone. So the video see-through mode is now applied mostly to the. It's also applied to mobile phone apps. AR. So this is some of the old video see-through in the past. So you can see this camera here on right on top to generate stereoscopic with right eye, left eye. Okay. The reason they position awkwardly right here, so they generate a viewpoint offset, try to minimize the offset of viewpoint. So instead of you're looking at them and you can't see your camera is, let's say your camera is on top, so you always see that your eye is actually above your actual location, your eye. So that is a attempt to design into the equipments. This one doesn't have a camera at all. So when we have to do a project, we have to duct tape the camera on top of just like in front of this display. Okay. But now that technology now you'll be appreciate later on in the practical that you have a lot more advanced now. So that's why this is our classic, uh, one of the really first few to introduce the AR to the general public. So that's our colleagues, my colleagues, Professor Mark Billinghurst. So that's, you know, up closer, the samurai character. That's a camera right in front of her display, and that's a physical object. What it does is that the camera here recognize a pattern, the pre-trained before using computer vision, and then recognize where the card is, and then that's the start, and then they can put the character where they are, and then if you move your card up inside and down or anywhere, they can recognize where should be putting that frame. Okay. So that is the general idea of the two mode, video see-through versus the optical see-through. So the brief history of AR, this is that way back into the very early age, the Professor Sutherland, he's now in the 90s. He came up with the very first known system. Okay, so this one is in the military, in the university. Okay, the one on the ball of the head here, the sharp mechanical arm here, is really its tracking system. Remember, this is in 60s. There's no advanced tracking system except that one. So essentially, that was a degree of freedom to keep moving ahead. So he can't move too far, which is that. But his position, every tiny movements of his display, which is high mounted to his head, is being captured by that device. Okay, and then you have his stereoscopic lens display device here. Okay, and the one that he hold in his hand here is a stylus to interact with the virtual contents inside his views. For example, you can have a virtual contents here. How will you move that? There's no hand tracking like what we do now. So you should use this track object just like that spider. Okay, but that one can move it. You can touch that object and can draw, can select those kind of things. So created interaction. Okay. And at the same time, military, this is my former, this is my PhD supervisor, Professor Tom Furness, when he was much younger. So he was work for military, design what program called Virtual Cockpit, which nowadays had been kind of used in Air Force. So essentially, the idea here is that before that time, this is 60, so this is 50 years ago, everything is a manual, quite manual. You see, you look outside cockpit and you see object and things like that, and then you have the little monitors just between your legs in the cockpit that you have to see where you target. This is all about putting information right in front of your view, so that you actually information are tied to where you want to see, and that could be combined. Okay, combined where the it could be aiming targets. Could be on. So this is a one. It's one of prototype. One of its prototype. And then in the but that's in the 60s. So now things are kind of, not really get out to the public. This is when industry start to look. This is one of the Boeing concept idea. Okay, in the mid 90s. So it allow you to kind of image on the left hand here is people who try to do a prototype of manufacturing, how to wire a cable on a board and things like that. That the system provide augmented help. That actually are visual guides, components, maybe instruction. As you can see, this is a conceptual drawing. Nowadays, actually started coming back with a more advanced AI headset, so some of these are possible. So you look at certain location, and then certain annotation come up, things like that. But this is one of the things that AR that you have. You should I should point out is that AR is simply an interface device. It's to be able to recognize where the object they were looking at. That requires some object recognition. So some of them will grind into the AI, artificial intelligence components, to recognize what they are. And then AR, augmented reality, are simply put that information you already have instead of iPad now putting in your field of view. Okay, and this is from UNC, University of North Carolina. It has a big group in the mid 90s about ultrasonic group, but they're also using that funding to support their view of how to do uh, what they call a Superman vision, so that when you see through before the surgery can happen. So in this case here is a view you can see inside. This is not a real patient; it's a skin pig skin, and then basically how to do minimal surgery. Okay, surgery so that means now with nowadays technology like scanning, CAT, and MRIs are available. So now how the surgeon is actually be able to use that on the spot, okay, to allow him to know okay where to cut, where to have a minimal damage that has a minimal damage, where to insert things like that. So this is able to render things behind it. Okay. And then it be in a bit of in commercial. Okay, so this one is on the left here is image from a group, wearable groups. Okay, so which is really start to combine with AR group. Uh, and this is a first known commercial AR apps. So this is American football. The AR augmented content is that blue line, not yellow line there. Okay. Remember the cameras are move panning from time to time. So those lines need to stay there instead of stay on the frame. They have to stay on the field as far as the viewer is concerned. So that means the camera pan or the zoom change and things like that. That line need to be adjusted accordingly. And that process is augmentation. It's a part of the AR. Okay. So you can see here some kind of step that AI start to taking step now. So now this is about mid 90s. Now AI is everywhere. Now it's people start to try to see what they become of what. Last 5 years ago was about Pokemon Go. That's one of the application in AR that people look at them. Okay, so how to get the virtual content coexist in the real world? How does that make sense? So that create a lot of intake awareness for the people to know about the technology. So some of the application here in AR, okay, VR is quite really focused. AI is quite broad in the sense that this one I will talk about at the UNC before. You can see here a little close up what the model inside would look like. How would you see them before? Just ignore the marker. That was just a technical limitation at that time. They need some physical, what they call fiducials or physical marker to be able to allow your AR camera to track okay, where you're moving as the surgeon or the user is moving around. So the virtual contents and the augmented content need to stabilize in space and appear at the same location. And some of these as a Siemens work up in New Jersey, near New York. So this one is stereoscopic. Okay, has a two camera on the top. Okay, that send in the real world video real world to come to the stereoscopic display at the bottom here. Okay, and these one with a little LED around them. This is part of their tracking system. Okay, and the tracking marker in this case, instead of pattern, they have this marker that got ingrained into the human subject. Okay, this is similar to technology that people Hollywood are using for their special effect these days. So it has a lot of dot things that you might have seen in the real the make of those movie. Okay, so that's what just allow them to be able to track the objects. Okay, so this case is the same thing. Okay, they try to look at where certain organ, certain part of the brain is located. Okay, so remember this is a static image. In the real world, I think what the benefits are, they'll be able to move around, and then there was scan MRI version of this thing that they can interact. Basically, they can drag across cross section view things. Remember that, but one thing that you will start to realize that there's a very real difficulty in getting this to work in a real life because most of these works are very early when they came out, and just for the researcher point of view, researcher from the researcher in interface like myself. However, you haven't really seen them in full function yet in the real world after many years, because there was a real technical issue that is not quite easily. Building a mock-up is relatively simpler. Okay. But anyhow, I understand the view a little bit. Okay. This one is also used. I think this one is start to make a real impact in the real world now. Okay, with the current technology. So this one is assembly. Try to get to maintenance the object. You might find that, oh, okay, if you have a training, why will you need help? Okay, just try to imagine if you are how much people time they have to train the people who do the maintenance, and then they have to go to location. What happened? It would be better to send an inexperienced, less well trained, but go in there and remote video in and have the other person kind of looking from the distance and be able to interact and has a augmented content to guide them, like visual in this case, like this one. This one just to fix a simple machine. Okay, but nowadays people can talk into, like Microsoft HoloLens has a program called 360 Dynamics. I think, yeah, I think it's called 360 Dynamics, that allow people to like Skype in, okay, but have ability to annotate it, okay, in space. Okay, so that means that they can see the same image here. I can draw something here, and the people on the ground, on location, can actually see what I'm drawing on the objects. Okay, so in that case, it's quite we moving quite a bit of this, quite advanced in that space. Now, next one is annotation. This is quite simple. Okay, this I think this you will see in some of these already in the current today. Okay, so AR annotation. So in this case, is for example, the system can annotate the object, or that's where the Philips Towers. This is where the objects are. It's just like Google Street, not Google Street View, Google Map, but it's on in 3D. Okay, so you should have annotation. So people are dealing with occlusion, the best way to navigate 3D. Unlike 2D, there's no obstruction. You see the top view of the Google Map, and you can see where they're going. But in 3D, everything in front of you, you not necessarily want to annotate everything that in your line of sight, because you can't really see them in the real world quite yet. That become a research by itself how to navigate those. Okay. So, but that's a sort of simple idea. And this is where people thought when the mobile phone start to become a little bit more powerful, that, oh, we should do this. We should have this annotation, Facebook accounts, and have the person name. Of course, this go to a very heavily privacy issues. Okay, so this idea is really a very cautious, very difficult one to get people to accept it. Okay, so but anyhow, it's very difficult as well. Another thing is that the holding of the device is also a tricky part, because how long can you hold a device like that to be useful? So that's why the idea pushing between using a mobile device and headset and things like that are being considered along the process of the design. This one is actually what HitLab in New Zealand is actually doing well. So they spin that technology with a marker, with a samurai 3D character to be a museum, interactive, music component. So people, instead of headsets, they now have a handheld, but it's just a front end of display that they can see. They have a navigation, and this is their mirror view on the top, so other people can see. And then this is some sort of music components. Whatever they interact with the physical marker here will generate a different reaction to the sound or the image, things like that. So become an interactive experience. This one we done it very quickly. So this one I talked about that American football before. This one is baseball. So you have this velocity here that show up, okay, in the current view. So that's this augmentation as well. Okay. And also in education. Okay, so education, people interacting. Okay, so the two character, two card playing, and then they create a story, and people can the educators can try to provide a real content inside a new medium, which is the AR storytelling. Hopefully, to be able to get more involved engagement. One of the difficulty for these one is that it's easy to generate the new things. Okay, people are excited to play with it, but it's really difficult to show the real benefit of it after 5 year, 10 years. So the similar thing with a lot of the prototype that we done in the medical. This is just as much. It's not as straightforward as you might think. Okay? Because one people get over the idea that it's a new thing, it becomes just another thing. Okay? Whether it's real the benefit or not, that's a difficult. Ethan, so is it difficult to calculate the light position? You mean this one? Oh yeah, so the light conditions is what in this prototype don't even talk about that. The light condition is actually applied to your more advanced AR in mobile now. Okay, so your virtual contents could have the light that kind of similar, the model, the lighting condition of the light that's similar to the real environments. Yeah, so the illusion, one of the main problem now is also photorealistic rendering of the AR stuff of the contents, because the AR contents is it's a virtual content, same content with VR, but they sit inside the real world. So if you just putting a virtual content there, look very odd, but you just want them to believe it's part of that. That's become a you're pushing the requirement of photorealistic realism to be high. So that was research in computer graphics that look into that. So that's one of the area I'll cover briefly at the future research. And this one is general ideas. Instead of you have the audio phone, instead you have AR, not audio phone, audio tour, where you have this, and then you walk to a location and you look at your physical map, and then this is location number 2. So you hit the number 2 button on your audio tour and then talk about it. In this case, the whole system tied with the GPS thing, and basically people can look at the different story at different locations. So creating this storytelling location, but it's not linear. So therefore, it's a story. But this for the museum perfectly fine. So you don't have chapter 1, chapter 2, chapter 3. So you can. It depends on where you start walking, where start you engaging. You might be looking at the back end of the building, or in terms of history wise. But this kind of system is it's a really research oriented component. Okay, so you can see here there was a virtual what people look like back then and things like that. Yeah, so and then try to render it into that space. Okay. This one is more Lego. Okay, I think where it's happened with video. So this Lego part is actually is let me grab this. I think the video link is work. Just give me a second. So essentially here, if you go to, you have the box and you try to grab the box and look into that's the yellow box here. Yellow box which simply generating and has a camera sit on top. You might not see it. So what they see here, they see part of themselves. They see themselves pass it to the camera, and they see the 3D character of that the Lego set completely built inside 3D. So what they actually and play some animation there. Okay, the difference here is also if you move around those box, just like those cardboard that it has a 3D samurai character on it, you start to see them move accordingly. Okay, just give me a second. Yeah, but you probably can imagine what they look like. Okay, so that's this kind of give you an overview quickly on what AR and VR is. For AR here, so I think we'll talk about that. Most of us were probably looking at the webcams and or maybe mobile phone. And when I say mobile phone, it's simply just Android device. Okay, we don't cover in this unit. We don't support the iOS. Okay, because it wasn't support well inside our unit, and it requires some developer license, and also has some copy of Microsoft HoloLens. Okay. So we'll get a chance to play with that if you chose to come along with the practical next week. I mean, for webcam and mobile device, you can always add that. And I like just similar to week 2, week we have week reading assignments, so you can get a chance to look into this. Okay, so on Milo there's a folder called um, readings, so you can take a look. This is one of the most cited paper in the field, written not just because it written many years ago. It was encapsulate what the ARs look like, and the way he written, just like the first reading reference by Tom Furness, it's easy to read, so I understand it's less technical issues, technical reading, so it's much easier for you to get the idea of what they were trying to communicate. All right, any question? This is the end of my introduction to AR VR. All right, oh good. So let me stop the